In this video, we will take a look at two real-life applications of logarithms, which are the Richter scale and the decibel unit. The Richter scale is used to measure the strength of earthquakes, and the decibel unit is used to measure the sound level. The Richter magnitude of an earthquake is determined by this formula, the logarithm of A over A naught. A is the amplitude of the seismic wave measured during the earthquake, and A naught means the amplitude for which the Richter magnitude is equal to 0. Technically, A naught is chosen to be 0.001 mm for the epicentral distance of 100 km. However, these details are not the focus of this video. Mathematically, the logarithm of A over A naught is equal to log A minus log A naught. And then we can see that when A is equal to A naught, the Richter magnitude is equal to 0. On the other hand, for the measurement of the sound level, we have a similar formula. The sound level measured in bell is determined by this formula, the logarithm of I over I naught. I is the intensity of the sound wave, and I naught means the intensity for which the sound level in bell is equal to 0. In physics, the intensity of sound waves means the power carried per unit area, and I naught is chosen to be 10 to the power minus 12 watt per meter square, which is the intensity of the sound that a normal human being can just hear. Again, these technical details are not the focus of this video. Conventionally, the unit bell is rarely used, and we prefer to use the unit decibel. Deci means 1 over 10, so the relation between dB and B is just like mm and cm. Therefore, the sound level in dB is given by 10 times the logarithm of I over I naught. Mathematically, 10 times log I over I naught is equal to 10 times log I minus log I naught. And then we can see that when I is equal to I naught, the sound level in dB is equal to 0. These two diagrams show how the Richter magnitude and the sound level in dB relate to the physical effects. Let's take a look at these calculations and gain an insight into the mathematical interpretation of these numbers. Suppose there are two earthquakes with two amplitudes A1 and A2. Then the difference in their Richter magnitudes is just equal to the logarithm of A2 over A1, which is equal to the difference of their logarithms. That means if the ratio of the amplitudes is 10 to 1, then the difference in the Richter magnitude is just log 10, which is just equal to 1. If the ratio of the amplitudes is 100 to 1, then the difference in the Richter magnitude is log 100, which is equal to 2. If the amplitude is 1000 times as large as the other one, then the Richter scale will increase by 3. If the amplitude is 10,000 times as large as the other one, then the Richter scale will increase by 4. In other words, each one level increase in the Richter magnitude means the new amplitude is 10 times the original. On the other hand, suppose there are two sound intensities I1 and I2. Then similarly, the difference in dB is just equal to 10 times the logarithm of I2 over I1, which is equal to 10 times the difference of their logarithms. That means if the ratio of the intensities is 10 to 1, then the difference in bell is just 1, and the difference in dB is 10. If the ratio of the intensities is 100 to 1, then the difference in bell is 2, and the difference in dB is 20, and so on and so forth. In other words, each 10 dB increase in the sound level means the new intensity is 10 times the original. Now let's take a look at two examples and see how we can handle mathematical problems related to the Richter scale and decibel. In the first example, the magnitude of an earthquake in an area was recorded to be 8.5 on the Richter scale. A few hours later, an aftershock of magnitude 6.7 occurred in the same area. How many times was the amplitude of the first earthquake as large as that of the aftershock? Firstly, we can let A1 and A2 be the amplitudes of the first and the second earthquakes respectively. Then we have learned that the difference in the Richter scale can be expressed as the logarithm of A1 over A2. So we know that the logarithm of A1 over A2 is equal to 1.8. As a result, we can get that the ratio of A1 to A2 is equal to 10 to the power 1.8. And it is equal to 63 correct to the nearest integer. Therefore, we can conclude that the first earthquake is 63 times as large as that of the aftershock. Finally, let's take a look at this example. The intensity level of a sound produced by a machine is increased by 5 dB. Will the new intensity of the sound be 5 times the original? Explain your answer. Please note that intensity level and intensity are different. The intensity level is the level in dB, while the intensity means I, which is the power of the sound per unit area. Firstly, we can let I1 and I2 be the original and the new intensities respectively. Then we have learned that the difference in dB can be expressed as 10 times the logarithm of I2 over I1. So we know that the logarithm of I2 over I1 is equal to 0.5. As a result, we can get that the ratio of I2 to I1 is equal to 10 to the power 0.5. And it is not equal to 5. Therefore, we can conclude that the new intensity will not be 5 times the original. This is how we can handle mathematical problems related to the Richter scale and decibel.